Hi everyone, my name is Thomas Kim. Today is 20th of November 2018. This is second episode about Windows API programming. In this session, we will learn various dynamic memory allocation in Windows API. If you haven't watched my previous video, please watch this video, Windows API 01, frequently used dynamic memory allocation pattern in Windows API. Understanding the contents of this video is very important to understand this session. Please download the source code from our previous session. We will learn how Windows API allocates dynamic memory in various ways. Most of the time, Windows API uses three dynamic allocation methods: CoTaskMemAlloc, or sometimes GlobalAllocate and LocalAllocate. In case of memory allocate and the new C++ dynamic memory allocation operator new, because these are C or C++ language dependent, Windows API do not use these allocation methods. Instead, most of Windows API use these three functions. In this session, we will learn each of these functions and how to use them. More about comparing memory allocation methods, please visit this website in Microsoft MSDN. In this website, you can read more about memory allocation method in Windows API. In this session, we will not deal heap allocate and virtual allocate. When the need arises, I will further talk about these allocation methods in future videos. In this session, we will mainly concern about three allocation methods frequently used in Windows API. Because we are using a sample code from our previous session, please download our previous source code by clicking this link. When download is completed, please unzip it and open it in Visual Studio 2015. Please note that I am using Visual Studio 2015. I will add a new project, Visual C++, Win32, Win32 console application here, global, local, CoTaskAllocate. Click OK. Next. Please select console application, precompile the header, security development lifecycle SDL check, then click finish. Right click new project, set as a startup, change it to Win x86, save all. From our previous project, I will copy the whole source code and paste it here. Then I will remove this part and close all but this. I left only this file. This is previous state of our program. I will press Ctrl F5 to build and run. Okay, it works as expected. Now I will copy this part of code from here. Win API pattern from here. I will copy till here. Test Win API pattern copied, and I paste it here like this. Then I will change the name GlobalAlloc pattern. I changed the function name like this. Then I will copy this function name to here and to here. Then I will also change it test Win API GlobalAlloc pattern. Okay, I change it. Please note that I will make further changes in this function. First, we will change it to GlobalAlloc. Then here GPTR. Please note that GPTR stands for global pointer. Okay, global pointer. So GPTR means global pointer, global allocation returns pointer. GPTR means global ALLOC returns pointer. Also, for your cross reference, GHND means GlobalHandle, stands for GlobalHandle GHND means global, ALLOC returns handle. Okay, in this case it is returning pointer. Now scroll down. In this function we allocate global memory, this win API function. Then we have to free global free. Okay, so we have, if we allocate memory, because this function allocates memory using global allocate, we have to free global free, and we will test this function. Test win API global allocate pattern. Now save, Ctrl F5 to build and run. Okay, it works. When you read MSDN documentation about Windows API function, if the function says, MSDN documentation says you have to free with global free, then the memory is allocated using global allocate. Okay, now I will copy this one once again. Now we will use local allocate, copy, paste, then scroll up. At this point we change it to local allocate. I changed this function name. I copied and paste it here, also paste it here. I change it to local allocate like this. And also please note that we are changing it to, in this function local allocate, we change it to local allocate. Please note that we have to use LPTR. So here LPTR stands for local pointer, and LPTR means local allocate, AL returns pointer, and also LHND stands for LocalHandle, and LHND means local allocate returns handle. Okay, about the returning handle I will talk more about this shortly. Now save. Since we allocated using local allocate, in this function it returns memory allocated using local allocate, we have to use local free. Then here we test like this. Test win API local allocate pattern. Ctrl F5. Okay, it runs successfully, and we'll copy once again from here. I copied and pasted. Now I will change it CO task MEMALLOC. I changed like this. I will copy this, and here I change once, twice. Then I will also change this function name, CoTaskMemAlloc. I changed like this. Now in this function we will use CoTaskMemAllocate, and it just needs byte size like this. I saved it. This function returns LP void. Since we allocated using CoTaskMemAllocate, here we also have to free using CoTaskMemFree. Okay, so we will test this function now. Ctrl F5. Okay, it works successfully. So here I will summarize like this. Here, since MALLOC and new are language dependent, Windows API functions do not use MALLOC and new. Okay, here CoTaskMemAlloc supports C, C++, and Visual Basic. CoTaskMemAllocate function supports C, C++, Visual Basic, and is COM-based memory allocation function. COM means component object model. Okay, so in case of global and local, global allocate and local allocate are from 16-bit Windows API extended to Win32 and x64. Please note that this global allocate and local allocate supports not only Win32 but also x86. For example, if we change it to x86, if we enable these two tests, this is global allocate, this is local allocate, and in x64 this function still works. Okay, it still works. Going back here, both global allocate and local allocate allocates memory on the default process heap. But some Windows APIs allocates memory using global allocate, and some other Windows API allocates memory using local allocate. So when you use Windows API function, you have to read the documentation carefully, and you have to know which function to free the allocated memory. Memory allocated using global allocate should be freed using GlobalFree function, and also memory allocated using local allocate should be freed using local allocate. Okay, there is another point you should keep in mind. That global allocate GPTR global pointer means, and we provide byte size returns pointer, and global ALLOC GHandle byte size returns handle. Also local allocate LPTR byte size returns pointer. Local allocate LHhandle byte size returns handle. If local allocate function returns pointer, then we can typecast to pointer. If global allocate returns handle, then we have to GlobalLock, then we can typecast to pointer. Okay, after use we have to GlobalUnlock handle, then we can GlobalFree. In the same manner, if local allocate returns pointer, then we can typecast to pointer. If local allocate returns handle, then we have to LocalLock, then we can typecast to pointer. After use, we have to LocalUnlock, then we can LocalFree. Okay, please remember this point. Also, if global allocate or local allocate returns a handle, then the allocated memory can be moved. Now we will implement this concept in our program. I will test just only one GlobalLock. I will copy this part of code. I copied this part of code, then here paste, then I will change global allocate handle HND. I changed it to HND. I will copy this part and I will change it, then I will also change HND. HND means handle, and we have to change code here. I will change like this, paste here, HGlobal is a handle, then it should be GHND, it returns handle now. We have to check if handle is valid. If handle is not null, please note that I am making block here like this, and I remove else clause here. So I modify like this, and now if it is not null, then we have to GlobalLock. This function returns void pointer, so we have to do like this. We first have to lock the handle, then it converts to pointer like this. Okay, so the rest is the same. I save, and the rest is the same. Since we locked the handle, in this function. After use, here the handle is still locked here. We have to free global unlock. We have to unlock the handle P my object. We unlock, then we free. Please, we should not forget this part. Save. Now we test this function. I will disable it. Disable it. Now Control F5. Okay, it runs successfully. Finally, I will do once again for local allocate. For local allocate, I will copy this part. Local allocate up to this point. I copied and paste it here. Then I change function name like local allocate HND. HND means handle. We save it here the same manner. Cut, paste here local handle, and we have to change it to LHND local handle. Then in the same manner, if handle not null, then we close block here. Then LocalLock handle. Okay, we save. I adjusted a little bit, and we have to remove else clause here like this. Then since we locked the handle before we free, I will change it H and D. Save. Before we free, we have to unlock. Local unlock P my object. Okay, I save this. Then we test this function. Control F5. Okay, it runs successfully. Sorry, I just found there is two errors in this code. In this function, we have to copy this part of code here and also here. Save. Then Control F5 to build and run again. Okay, it runs successfully. I'm very sorry, there is two more errors. Here in class view, select this global function, global allocate handle pattern. Here I have to fix like this. H global handle, global handle. Since we are using pointer, this is pointer, we have to convert it to handle first. P my object. We convert pointer to handle. Then we have to unlock like this handle, unlock global handle. Then we have to free like this way. Now once again save it. Then here in this function also, this is H local handle. It is local handle like this. P my object. We have to convert pointer to handle. Then we have to unlock handle. Then we have to free handle like this. I'm very sorry. So I fixed errors, more errors. Then I enable this. This is global local. Okay, now Control F5. Okay, it runs successfully. At this point, you probably wonder what is the difference between global allocate and local allocate. MSDN documentation about global and local function. MSDN documentation says Windows memory management does not provide separate local heap and global heap as 16-bit Windows does. As a result, the global and local family of functions are equivalent, and choosing between them is a matter of personal preference. So it means there is no difference between global allocate and local allocate. But some Windows API functions use global functions that are still used with dynamic data exchange and clipboard function and OLE data object. For such functions, GlobalAllocate is used, but basically as a result, the global and local family of functions are equivalent, and choosing between them is a matter of personal preference. It means there is no difference. I hope you enjoyed this session, and this session is not actually perfect. There are still some missing points in this episode. In next session, I will fill the missing points about memory allocation. Thank you for watching.